Hello, this is Mr. Collier, and today we're doing some applications involving right triangles. So in this example, Julia finds that it's quicker to go to school across the diagonal of a paddock than walking across the sides. The diagonal is 85 meters long, one side is 42. Find the length of the other side of the paddock. So that would be, in this example, I can label it x. And we can use, in this case, the Pythagorean theorem to find x. So the right angle is here. That means this is the hypotenuse. So we have 85 squared equals 42 squared plus x squared. And I can solve by doing minus 42 squared from both sides, and we get 85 squared minus 42 squared equals x squared. Okay, so I'm going to do that on my calculator. And we have 85 squared minus 42 squared is 5,461. 5,461, and if we want to get x, we'll take the square root of that. And that's going to be, so second function root, second function answer. So take the square root of the answer, and we get 73.9. So that should be a 1 here, and that's 73, approximately 73.9 meters. Don't forget your units. Okay, next example. Firstly, let's look at a couple terms that we need. Firstly, angle of elevation, and then we have angle of depression. Okay, these angles are always made with a horizontal line, either like an imaginary line in the sky, horizontal, or the ground maybe. Okay, and angle of elevation is always up, like when you're looking up from the horizontal line. Angle of depression is down from the horizontal line. So if you're down here looking at the balloon, this here is the angle of elevation. Okay, an angle of depression is always down from the horizontal. Okay, you can remember that because there's a D in depression. So we're going to take a look at some word problems using those terms. Find the angle of elevation to the top of a 56-meter high building. So angle of elevation, this is the horizontal here. So angle of elevation is right here. So we call that x, I guess. So we're going to find that first, and we can use SOHCAHTOA, trigonometry. And in this triangle we have opposite and adjacent, so we're going to use tangent. So tangent of x equals 56 out of 113. So to get x here, we have to do inverse tan of 56 out of 113. And I'll do that in the calculator. Second function, tan, 56 out of 113. And we get 23.6. So that's approximately 20. So 23.6 degrees. What is the angle of depression from the top of the building to A? Now, so actually in this case, angle of depression and the angle of elevation are equal to each other here. Okay, because these are parallel lines, these angles are equal to each other, so it's the same thing as what we just got. Okay, in this one, the angle of depression from the top of a cliff to a boat is 16 degrees. So let's draw this line in from the top of the cliff to the boat, and the angle of depression is 16 degrees. So we have to draw the horizontal. Depression is down from the horizontal, so that is 16 degrees. Okay, so that's 60 degrees. How far is the boat from the base of the cliff? So that we'll call this x over here. So because that is 16 degrees, and this angle down here is also going to be 16 degrees, and then we can solve it using trigonometry. So we have SOHCAHTOA, and to find x here we're going to use opposite and adjacent, so again that's tangent. So tan 16 equals 120 out of x, and I'll solve for x times x both sides, then divide by tan 16. So we'll have x equals 120 out of tan 16. And I'll do that on the calculator. And I get about 418, three significant figures, 418 meters. Okay. Last example. Okay, in the last example, an airplane is flying at 10,000 meters and is at an angle of elevation of 36 degrees. Okay, so you're looking at this airplane. It's up here, and this is at the ground. The angle of elevation is 36, so here's the ground. I'll try to draw a straight line. The angle of elevation here is 36 degrees. 2 minutes later, the angle of elevation is 21 degrees. So that means the airplane is farther away because the angle, I'm going to draw this in a different color, the angle is smaller. So now it's farther away, so we have a different angle, which is 21 degrees. So the further the airplane goes in this direction, the smaller the angle of elevation is going to be. Okay, so it's flying at a height of 10,000. So we can draw some triangles here. This is 10,000 meters. I can complete this red triangle here. That's going to be 10,000 meters. Okay, so we use trigonometry to figure out the speed of the plane. Remember, speed equals distance divided by time. Okay, so we need to find the distance that it traveled from here to here. So we need to find, let's say we'll find x here in this small triangle, and then y is the distance here in this bigger triangle. So to find x, we have like opposite over adjacent, so we use tan. Tan 36 degrees equals 10,000 out of x. So we're going to get x equals, if you solve, you're going to get 10,000 out of tan 36. And for y, you're going to get tan 21 degrees equals 10,000 out of y. So we're going to have y equals 10,000 out of tan 21. Okay, so let's work out those two on the calculator. So firstly, 10,000 divided by tan 36. That is 13,764. 13,764 about. And we're going to work out y with the calculator. 10,000 divided by tan 21. So that's similar to my last calculation, so I'm going to do second function entry and just change this to a 21. Let's enter 26,051. 26,051. Yep. Okay. So that's that. Now we want to find the speed of the airplane. So speed is just going along here. So we need this distance here, which I'm going to call z. Okay? Well, that's just going to be y minus x. So we're just going to say z equals 26,051 minus 13,764. So I'm going to subtract 13,764. Subtract 13,764. Gives me 12,287. 12,287. Okay, so that is the distance traveled in that period of time. It took 2 minutes. In 2 minutes. So that's 12,287. Now maybe we want to get speed per hour. So how many minutes are there in an hour? There's 60 minutes in an hour, so this is 2/60ths of an hour. That's one way we can do it. We have a calculator handy, so we can actually do this calculation. Okay? And I want my answer maybe to be in kilometers per hour, so I'm going to do 12.287 kilometers per 2/60ths of an hour and get my answer in kilometers per hour. So 12.287 out of 2 out of 60. And I get 368, or 369 around 3 7 figures. So that's about 369 kilometers per hour.